And I have found over the years that one of the thing that people say they most want help with when they take Digital Logic 2 is Verilog. So I'm hoping that I can use these reviews and kind of remind y'all of how to do some stuff, and maybe these recordings can be used in the future for reference as well. So the first few problems are pretty basic, and then we'll get further on, and then we'll get things that are more like what you have to do for the homework. But it's just, all of these are just kind of reminding you of some of this stuff that you probably saw in 2741, but it couldn't hurt to have a little review of it. So these problems are the ones that Dr. Vedi assigned, and didn't assign, but he gave to you for practice. And typically, if he says to do them for practice, that means that's what he wants you to know how to do, and it will help you do the ones that you need to do to turn in for credit. So that's why I'm doing them here. So this first one says, this was problem 260 in your textbook, to write Verilog code to implement this circuit using gate level primitives. So gate level primitives, you don't really use this very often at all. So this is just to kind of remind you of how to do it. This is not really going to be what you're going to do unless you see it on a test or for something that you have to turn in. So in a gate level primitives, this is where you actually are telling it exactly what gates you would want. So it's like you draw the circuit and you say, this is what I want. So with any Verilog, actually, I think what I'm going to do, it'll be neater. I'm actually going to type since it's Verilog. It always starts with module. So you'll do module. Let's see if that's big enough. Okay, so module, and then you give it a name, and you can call it whatever you want. So I'll call it problem 1. Problem 1. And then in parentheses, what we're going to put in is what our inputs and our outputs are. And so if we look at our circuit here, don't know how big that is on your screen. Our inputs are X1, X2, and X3, and our output is F. So I can put these in any order for right now. Any order is okay. So X1, X2, X3, and F. Now the only reason the order might matter later is if you are using this module in another module. So if you're calling this module from some other module, then you need to pay attention to the order you have here. Then the next thing you do is the same as with any Verilog. You tell it which ones are your inputs and which ones are your outputs. And since X1, 2, and 3 are our inputs, there we go. And our output is F. And then, because this is using gate level primitives, we just straight out say what gates we want to use. So I've got 3 NOT gates, so I'll just put NOT. And then the way the syntax for this works is the first thing that I put in here is it's a placeholder. It's like a variable name, but I don't have to declare it anywhere. This is what the output of this NOT gate is going to be called later on when I use it somewhere else. So I will call it just X1 in for X1 NOT. And I did not have to put that in as an input or an output or even as a wire. I'm just saying this is what the output of this NOT gate is going to be. And my input comes second. So that, what I just wrote right there is the first, the first NOT gate. And then the second NOT gate. Oh, great. Hold on. There we go. Okay, and then the second NOT gate is for X2, so I'll call its output X2 in, and that's X2. And my third NOT gate will be for X3, so that's X3 in and X3. Now I can use that X1, X2, X1 in, X2 in, X3 in as inputs for other gates. And that's exactly what I'm going to do with my AND gates. So if I look at this top AND gate, the top AND gate has as inputs x1 naught, x2 naught, and what's this last one? This last one is x3. So the way I do that is like with the NOT gates. I'll start with AND because it's an AND gate. And then the first thing that I put is going to be what its output is, and I'll just call it A. And then I'll put its three inputs, which was x1 in, x2 in, and x3. And then I'll do the next three AND gates. So the next AND gate has as its inputs let's see, that would be x1 naught, x1 naught, and x3 naught, and x2. Okay, so I'll call it B. I can call it whatever I want, so I'll call the output B. I apparently typed B over here. Okay, so B, and x1 in, and then x2 and x3 in. And then my next AND gate, I'll call its output C, and its inputs are x2 in, x3 in, and x1. And my last AND gate has x1, x2, and x3. Oops, but my output, put my output label first, so x1, D, and then x1, x2, x3. Okay, and then my final gate is an OR gate. Well, I didn't know you could do this. I was going to do this. I was going to type OR, and this is fine, OR, and then my output is F, and that's my final output, and I was going to put A, comma, B, comma, C, comma, D, and then end module. But I was looking, and no semicolon there. Apparently, you can also do, I believe what I get my computer languages mixed up a lot of times, so I want to, no, I think that's right. So for Verilog, I believe you comment with the double slash, so that takes that line out of there. You can also use the symbol for OR. So the symbol for OR is a vertical line. So the symbol for OR, and not just the word OR, F, comma, A, comma, B, comma, C, comma, D. And that would also be work as an OR gate. So that would, for a primitive level OR gate. All right. Now, I could also, another way I could do this a little bit quicker, if I wanted to, is I could, before I go on, for those of you who are watching this live, everybody has this. Can I erase this and change it? Okay, I'll assume that I can. I just know that, like, sometimes I take a class and I'm not going to say who the professor was. I don't know if this person is still teaching or not, but he would write the circuit on the board, and before I could get it in my notes and make comments on it, he would erase it and change something, and then he'd erase it and change something, and I never actually got the original circuit drawn. So I can, instead of those NOT gates, I can replace anything that I wanted to NOT with the NOT operator. Except, was that one a NOT? Yeah. And it has exactly the same effect. It does exactly the same thing. It's a little quicker to write, but it does exactly the same. So this is also using gate level primitives. So that little tilde there is also stands for a NOT gate. Okay,
I have a question.
Sure.
So, you use the symbol for or. So, could you use the symbol and for the and gate too?
I feel fairly certain you can, but as it was new to me when I saw it, um, I'm not entirely sure, but I will check on that real quick and make sure that you can. I can't imagine
Okay.
that you could use one and not the other, uh, but I will. Let me just check that real quick. So, uh, gate level modeling, syntax. I am going to say yes, and I'm going to let this computer finish loading. Wait, here we go. And okay, so I'll come back and check on that. I'm just gonna let this load on this computer, but I will come back and check. Um, so far, I'm not seeing anybody who's using it, but that doesn't mean that it's not possible. I will try it out and I will get back to you and let you know for sure. All the examples I'm seeing are using the words and not the symbols, but I will find out. Okay, and we can always pull up Vivato and see what actually works. All right. So this next one, um, we are going to do um, Verilog code. Oh, any other questions before I start the next one? All right. So we want Verilog code to implement this function, which is the sum of min terms 1, 2, 3, 4, 5, 6 using gate level primitives. So let's do this. So if you recall, uh, so if I list out all of my possibilities for x1 and x2, then my min terms, this is min term 0, min term 1, 2, 3, 4, 5, 6, 7. So those are my min terms, and those correspond to min term 1 is x1 bar, x2 bar, x3 bar. I mean, min term 0, because that's where they're all zeros, and that's min term 0. Min term 1 is x1 bar, x2 bar, x3. That's 0, 0, 1. So if I want the sum of min terms 1, 2, 3, 4, 5, 6, that would mean that all of these are 1 and only 0 is 0. And so if I did a Carnot map with x1, x2, x3, and 0, 0, 0, 1, 1, 1, 1, 0, and 0, 1. The only one that's 0 is right there. Everything else is 1. And so, let's see. So the best way to cover this would be certainly we want let's see if we can do better than. Does anyone see anything better than that? I've got 3 circles, each of them with 4. Seems like there should be something better than that, but I'm not seeing it right now.
Would 7 be a 0?
Would 7 be a 0? 7 would be a 0, thank you. I really appreciate that, because that I would have gone all the way through and gotten it wrong, and I make lots of mistakes. So 7 would be a 0, and 7 is 1, 1, 1. That's right here. So let me fix this. Okay, so 7 needs to be a 0. Okay, so now let's see. This is probably the best way to get those. And then
On the K map, is that a X2 or a Y2?
oh, it's my bad handwriting. It's an X2.
Oh, okay, okay.
Yeah, that's X1, X2. Let me flip my computer over. I'll write better when it's like this, but then you don't get to see me, and I'm sure that makes you very sad. Okay, so does anyone see anything better than that? Okay, so this would be then. So I have this group right here would be. Let's see, what do we have in common? X2 is 1, and X3 is 0. Or, and then this group right here, we have X X1 is 0, and X3 is 1. And then this group right here is X1 is 1 and X2 is 0. So we have that. So now another way to do it is we could do, so we did min terms. It might be easier to look at the max terms. So the max terms are where we have 0. And so our max terms would be, if I look at the first row, the max term that goes with that first row is x1 plus x2 plus x3. And rather than a sum of products, we do a product of sums, and this bottom row is x1 bar plus x2 bar plus x3 bar. So I believe either of those would work, and so they should give the same thing. If I were to multiply this out, I should end up with the same thing. So now we will do a Verilog to implement that circuit, and I think what I will do, I'll do the second example that I did. So I did the first one using the K-map. The second one was a little quicker to come at, so I'll do that one instead. So I will call this module problem 2. And my inputs are x1, x2, x3, and my output is F. And so input x1, x2, x3, output F. And then, so just looking at what I have here, I have 2 OR gates with 3 inputs. So I'll put an OR gate, and I'll call the output of that OR gate A. And my first OR gate will have x1, x2, x3. And my second OR gate will have not x1, not x2, not x3. But I need to put my output, so my output would be B. And then finally I'm ANDing those together, and the output of that is the output for my module, so that'll be the AND of A and B. So F goes first, and then A comma B, and then we'll end module. Okay, so any questions on that? Okay, so what I'm going to do right now is I am going to stop this recording and start uploading it, and then so y'all just talk amongst yourselves.